Hello and welcome back. For this video we're going to show how to solve systems of linear equations using the substitution method. First thing we want to do is define what a linear system is, or linear system of equations. It's a set of two or more linear equations that contain the same variables, and we call that a linear system of equations. The solution to a linear system of equations is the ordered pair that satisfies a solution to both equations simultaneously. There are different types of systems that we deal with. The first one's going to be called consistent, and that's a system that has at least one solution. So it could have more than one, but it's at least one. Now we could have an independent system. You can see it says a system that has exactly one solution. We have a dependent system, and that's a system that has infinitely many solutions. In an inconsistent system, there's no solutions. We sometimes refer to this as a parallel system. Here we have our first problem. Mr. Howell was given 100 textbook covers to sell to his homeroom. When sales were complete, a total of $84 was made and 40 covers remained. Textbook covers were sold as singles and as 3-packs. The single covers are sold for $1.50 each, and 3-packs were sold for $4 each. How many of each type of textbook cover was sold? But in order to solve this, I'm going to need two equations, and I am going to need some variables. I need two of them, because the question wants to know how many of each type of textbook cover was sold. So I have two types. I have a single pack, which I'm going to call G, and that's the number of single packs, and the number of 3-packs, which I'm going to call P. The first thing I'll note here is that I started with 100 textbook covers, and I ended with 40. If we do a quick little math there, we can tell that I sold 60 covers altogether. So if I start with the number of single packs, which is going to be G, so we'll just call that G, and I add to it the number of book covers that I sold in the 3-packs, and 3-packs are 3 each, so P times 3 gives me the number of covers that were sold in 3-packs. I know that that has to add up to 60 covers. So G plus 3 times the number of 3-packs I sold equals 60. That's one equation. The next equation comes from money earned. So earned a total of $84, and some of that came from singles and some of it came from 3-packs. So the singles were $1.50 each. So if G stands for the number of single packs, then multiplying that by $1.50 should give me the cost, or the money earned from single packs. And I can do the same thing with the 3-packs. Each 3-pack was sold for $4. So if I have P amount of 3-packs, then I times it by 4. I get the dollars, or the amount of income from 3-packs. So if I add those two together, it should come out to $84. Before I show you how to solve that system of equations, I'm going to show you what the essence of substitution is. Now, when you see a problem that looks like this, the curly braces just indicates you're dealing with both equations at the same time, and hence the word system. So what that means is the x and the y's in the system have to have the same equal values to be a solution. So if we had a problem that looked like that, we can clearly see that since y equals 17 and both these y's are the same, I can actually take the y out of the bottom one and substitute it with 17. So essentially this number goes down there. And now I have enough information to solve. So the effect, or the essence of the substitution method, is to eliminate one of the variables from the problem, leaving only one variable left. So if we end up solving this, we end up having, we subtract 5 on both sides, we end up with 12 equals 4x. X ends up equaling 3, so the solution would be 17 for y and 3 for x. Now that's substitution in its most basic form. Here's a little bit more challenging one. The top equation actually has an x and a y, so does the bottom. But notice that y is isolated by itself, and that y there has to be the same y that I have down here. So all we're going to do is rewrite that second equation, 2x plus 2, and instead of putting the y in there, I'm going to substitute that y with what y is equal to in both scenarios, which is 10x minus 5. So I'm just going to use the substitution method here, equals 12. And now you can see this equation right here only has one variable in it. And then I'm going to go ahead and solve that. So distribute. So we have 2x plus 20x minus 10 still equals 12. I'm going to combine my like terms first. So I have 22x minus 10 equals 12. Going to add 10 to both sides. This zeroes out. 22x plus 0 is 22x equals 22. And now I'm going to divide both sides by 22, and x ends up equaling 1. Now that's only half the solution, because an ordered pair is what makes the solution to a system. So out of this system, I know that x has to equal 1. But I got to go back and solve for the other variable, which was y. So I'm going to take this 1 that I have here, and I'm going to substitute it back in place of this x here, and that will give me the value of y. So I'm going to rewrite that equation, y equals 10 times 1 minus 5. Of course, 10 times 1 is 10, so y equals 10 minus 5. Y equals 5. So y equals 5. So the solution is actually 1 comma 5. Now you could list it like this here, but it's not uncommon to list the solution as an ordered pair, like you'd find it on a graph. Okay, so going back to this problem here, we have our system g plus 3p equals 60 and 150g plus 4p equals 84. Now, what's different about this problem than I showed on the last one was I don't have a single variable isolated in this case. So what I want to do is look at both equations and decide which one is easiest to get by itself. Well, it looks like the top equation I can isolate g very easily by rewriting that as g equals 60 minus 3p. So now I can substitute g with 60 minus 3 anywhere else I see g in the problem. So if you look at this problem over here, we can see we have a g right there, which means that g is the same as this g here, which means I can substitute it with 60 minus 3p, and that's what I'm going to do to solve. So I have 1.5, and I'm going to drop the 0 off there, and in place of g, I'm going to substitute this expression of 60 minus 3p, and then solve this problem for p, because you'll see that there's only one variable left in the problem, and that is the variable p. Now we're going to distribute. 1.5 times 60 will give us 90. 1.5 times negative 3p will give us negative 4.5p plus 4p equals 84. Now I want to combine my like terms here, so bring down the 90. So 90 equals, or 90, when I combine my like terms, I get negative 4.5 plus 4.5. That's going to leave me with a negative 0.5p equal to 84. Then I want to subtract 90 from both sides. So minus 90 minus 90. And we end up with negative 0.5p is equal to, now when I subtract 90 here, I get a negative 6. Now in order to get rid of my negative 0.5p, I have to divide both sides by negative 0.5. So when I divide by negative 0.5, divide by negative 0.5, I'll have p equal to 12. Well, remember, p stands for 3-packs, so I have 12 of the 3-packs. Now I got to go find out how many of the single packs I have. So I'm going to go back up to this equation here, because this is not the one I used down here. I use a different one. So I'm going to substitute 12 in place of p. So I have g plus 3 times 12. This was a p, but remember p is 12, equals 60. G plus 36 equals 60. Now I'm going to subtract 36 from both sides. G equals 24. So I have 24 of the single packs and 12 of the 3-packs.